Hello, everyone. My name is Isabelle Sebastian. I know you all have been listening to these awesome presentations for some time, so here's a brief overview of what we've been working on for the past 3 weeks. Our project is a plant identification and diagnosis AI. I'm happy to say that it successfully identifies certain fruit plant species, diagnoses diseases that the plant may have, and provides solutions to the identified diseases. Here in this image carousel, you can see a few examples of our AI's end product. Here we have tomato plant and snake plant that identifies with pretty good accuracy. Our team will also go over our purpose, work process, challenges we faced, and improvements we made. Ben, if you could scroll down a bit. Here's all the awesome people I got to work with, starting off with Srikar.
Hello, everyone. I'm Srikar Vemuri and a web dev backend enthusiast. I also absolutely love AI computer vision and, of course, AI camp.
I'm Buzard. I like playing the clarinet, and I've been programming in various CS fields for many years.
I'm Isabelle Sebastian. I started coding with JavaScript and Python, and I'm really starting to like machine learning.
Hi, I'm Ashley. I like painting during my free time, and I've had a love for coding and programming for several years.
I'm Justin Erdenebileg. I started coding C++ 2 years ago and then later moved on to Java. Now I like to code complex algorithms and AI.
I'm Nathan Zhou. I like engineering and reading any book that interests me.
And of course, our amazing instructor, Jin. Big shout out to him. He's great.
Let's go, Jin.
And now Justin for more on our process. Our purpose.
Okay. Our main purpose and goal for this AI are to help users take the best approach possible to treat any health issues that the plant may have. At some point, every beginner and experienced plant owner may run into an issue that they are unable to diagnose themselves, let alone treat. Our AI will be able to identify, diagnose, and provide solutions to various fruit plant concerns. With our AI, keeping your fruit plant alive and well will become much easier.
As a whole, the work process for these past 3 weeks establishes a great understanding of our individual milestones. The development of the model initially started out with data accumulation steps. Our team utilized SERP API for general web scraping through Google search, as well as the Beautiful Soup Python HTML parser for particular websites in order to have a substantial amount of data. In addition to these methods and an available data set solely for the diagnosis process, we used Kaggle. This resulted in us having about 7,500 plus raw images throughout our data sets derived from these particular processes. Step 2, afterward, we started to label and clean our data accordingly through RoboFlow software. Through the product development time period, there was much work tied to labeling due to the 2-step procedure implemented. Hence, we ended up with a total of 14 projects in RoboFlow, including the main identification and each separate fruit plant diagnosis model as well. Altogether, including the augmentation steps applied, there are a total of about 13,500 plus images cumulatively throughout all our data sets. Soon after the data sets were finalized, we began training the models through the YOLO v5 algorithm on Google Colab's GPU, RAM, and disk services. Since we had to train many models, we tended to alter many of the input parameters, such as the number of epochs or the batch size. For example, at one point, we decided to increase the number of epochs for the plant ID model from the default 100 to 200 epochs. Regardless of the decrease in accuracy that was a result of that specific situation, we were able to locate other pieces of the models that seemed to be disturbing the performance. This included the unnecessary null images set in our datasets. The model also provided us with metric data and our respective PyTorch files for deployment. For the final product, we developed this website through CoCalc while using HTML, CSS, which included a few pieces of the Bootstrap framework, and JavaScript code for the front end also. Similarly, we integrated our PyTorch model files through the Python Flask framework for our backend functionalities. Though after analyzing the model performance and in the interest of time, we only were able to implement 9 out of the 13 diagnosis models. As a general overview, our AI product is capable of taking an image of a plant, providing an output for identification, taking an image of a diseased leaf of the plant, and providing a diagnosis and solution based on the previous data. This will be demoed by Ben.
So for our model, we have a website here, and we first upload a picture of a plant. Here we use a tomato, and it shows the confidence and the detected plant. And it also shows the image of the plant with the confidence. And then after that, you can upload a disease for it. In this case, we're using early blight for it. And it gives you some links to treat the disease, and it gives the detected disease and the confidence, and it gives the image here. Down here, we talk about why the model sometimes misses, and we give the confusion. We have a confusion matrix for our identification model that identifies each plant we support, and we also give the confusion matrix for the specific plant was detected for detecting the diseases. Next, Ashley will talk about the challenges we had making this project.
So throughout this project, we all went through several challenges along the way. The biggest struggle process was labeling the 13,000 plus images that our 2 models consisted of. RoboFlow projects, which took the majority of our time during this 3-week process. Adding on, we had a lack of quality data for the diagnosis since we spent most of our time finding lots of data. Another challenge that we had was that the diagnosis accuracy is much lower than the identification accuracy because we did not have as much high quality data for the diagnosis. Now, Nathan.
So some improvements we could have made are including sufficient amounts of high quality data for each fruit's disease, focusing more time on the diagnosis as much as we did for the identification accuracy, and optimizing more time by searching for quality pre-labeled data sets. And some additions we could add to our product in the future are increasing the amount of plant species that we can identify, adding the majority of the disease for each plant to diagnose, and adding more unique data sets to increase accuracy, as well as adding more solution resources for the user.
Thank you so much for listening.
Sorry, I barely heard that. Was that thank you so much for listening?
Yes, yes, it was. Yeah, thank you so much.
All right.